Yeah, hello. Let's treat integral calculus today. Yeah, what from the topic integral calculus? What do we mean by integral calculus? Now, from here, we know actually under calculus we have the integral calculus generally is an aspect of mathematics. We have the integration, integral part, and we have the differential. So we have these two aspects. So already we have videos on differentiation. Now we're talking about integration. I want to start a series on integration. And why do we start first? Let's talk about integration, then we consider the indefinite integral. Then the indefinite integration, that will be treat first, then we move to the definite. Now, for indefinite, what exactly is integration? When we integrate, what are we doing? Now, the symbol for integration is this. This is a symbol. So it's generally we have that we integrate something, we have x raised to the power n. Integral of this, of course, the function, this is a function, and once we integrate it with respect to x, what do we have? We're going to be having what? We increase the power of x or the power of this variable with respect to this, because this variable we're integrating with this with respect to this x. If we increase the power, we're going to be having x raised to the power n plus 1 divided by, there's now a new power divided by this new power, then plus what? A constant which can be c or k. It can be another constant, but generally we use c and k. And those constants, they are called dummy constants. Quickly, let's consider something like this. Let's say we have y is equal to 20x cubed plus 4x. This is a function, right? Now, if we differentiate this function, what do we have? We have dy dx to be equal to what? When you differentiate, power multiply this, we have 40x. What do we do to this one? The power is reduced by 1. So 40x plus what? Plus 4. This is integration and differentiation of this. Now, if we want to get this function back, this is a function, we differentiate it with respect to x. With respect to this, give us this. If we want to get this function back, what do? We'll integrate this. Now, integrating the function, this will come back. We're going to have an integral of this. You get? Integral of this. Integrate both sides. If we integrate dy dx, what are we going to have? We're going to be having a different function. So what do we have? We're going to be having a function. So if you have the differentiation of the y integral, integrate dy dx, we're going to be having y. Originally, this is like y naught dy dx. What is y naught? Y raised to the power 0, I mean. So y raised to the power 0 is written as 1. So we are differentiating, we are integrating rather, don't mind me. Integrating y with respect to what? Integrating with respect to what? It's dy dx. If you integrate it, what we are going to be having 1. You get? So integrating that, and then becomes what? We have integral of 40x plus 4. So integrating this, what will this one give us? This one will give us what? I'm going to be having y raised to the power 0 plus 1 divided by 0 plus 1. Following the rule that whenever you integrate, increase the power by 1, everything divided by the new power, then we have what? Integral of this. Increase this by 1, we have 40x squared, right? Divided by the new power, which is 2, plus what? This one is like x raised to the power 0, right? So then we have 4x raised to the power 1 divided by 1. 0 plus 1. So what do we have? This one, this will still become what? Y raised to the power 1, which is y. Now because 2 here 1, 2 here 20. So 20x what? Square plus increase 1, I will give you 4x. Then plus c, a constant. So what are we having? We are having this question. We differentiated this question, we got this. Now integrating it, we are getting this back, the function. That means that Integration and differentiation, they are the opposite of each other. Let's continue. Let's see this question. The y dx is equal to this. Find y. We have differentiated a particular function. We now want to get the function back. That's the meaning. So what we have to integrate is just integrate, we have the y, the x, to be equal to 60x squared plus 4. Then integrate both sides, right? So this is just like y raised to the power 0, same thing as 1. So this one, divide the x of 1, integrate 1. We're going to divide the x. Y raised to the power 0 plus 1, which is 1. Y raised to the power 1, right? Integrating this one, we have 60x squared plus 1 over what? 3. Then plus what? 4. What? X. This is not x raised to the power 0, just like I did there. So what we have here now, we have 3 here, 1, 3 here, 20. That becomes 20x cubed plus 4x plus constant k. We have gotten the function back. We have gotten the function of y back. Now let's quickly, in this same video, let's talk about some basic integral functions. They have basic integral functions. What are we doing? What are we doing? We have basic integral functions. There are some functions that they are basic. You should know how to integrate them. Whether they are trigonometric functions, exponential functions, or call them basic integrals. How do you deal with them? If you have the integral of cos x, integral of sin x, you have integral of 1 divided by x. So let me call them basic integrals. We have integral of, let me start with cos x dx. What do we have? If we differentiate cos x, what do we have? We're going to be having minus sin x. But if you integrate this, you're going to be having sin x. So I can put a constant there. If you integrate sin x with respect to x, what will that give us? Normally, if you differentiate sin x, you get what? Cos x. But when you now integrate sin x, you have minus cos x. You see what? This is what I mean. Let's say y is equal to cos x. If you differentiate cos x, the y dx of this function should give us minus sin x. Right? Now, if you integrate both sides, you want to get the function back. Already, you're integrating. So this is what this means that y, you have dy dx is equal to minus integral of sin x. Minus is just minus 1 can come out. It's just a sign, right? So then it's not integrating sin x now. What are you going to have? So you are going to be having minus what? Minus open brackets. When it's integrated, we have minus cos x. So what we have, that means y is equal to what? Cos x. So that means that in the integral of this will give us this. The integral of minus sin x will give us cos x. Because there's a negative sign already here, bring it out. Integrate sin x, there only was minus cos x. I've gotten back this function. Are you seeing that? So that means if you integrate sin x, you should have minus cos x. Which other function we have? If you integrate 1 upon x, the x, we will have remaining x. Put the constants. Are you getting that? If you integrate the reciprocal of x, we have the log or natural log of x. So if you have again, if you have the integral of exponential x, it will still give us what? Exponential x. And why this apply different rules actually? If you are, whenever you are integrating exponential of any function, you are going to be differentiating that function. Whenever you have that function divided by whatever you have as an answer. So that if you differentiate x, you have 1. So this over 1 is the exponential of x. Okay. So in the next video, we'll talk about more about some other functions and all of that. Thank you for staying with me.